Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this video, I will explain S2 linear combinations of random variables, in short LCRV, in detail, along with practice questions. Stay focused and watch the lecture carefully. We should be kind to everyone. Let's begin. Linear combinations of variables. In S1 we did normal distribution and it was for single variable. For example, x is normal with mean mu and variance sigma square. And here is the formula of z. X minus mu divided by sigma square under root. In S2 we do linear combinations of random variables. We have two variables. X is normal with mean mu1 variance sigma 1 square. And y is also normal with mean mu2 and variance sigma 2 square. Their sum x plus y, this is also normal because both are normal. So x plus y is normal with mean mu1 plus mu2 and variance is sigma 1 square plus sigma 2 square. And the formula of z is x plus y is here, their mean is here and their variance is here with under root. So this is the comparison between S1's normal distribution and S2 linear combinations of random variables. Types of questions. The volumes in liters of juice in large and small bottles, see there are two variables, have the distributions, both are normally distributed. Find the probability that the total means sum, volume of juice in three randomly chosen large bottles. So L1 plus L2 plus L3. That means sum of three independent large bottles. And four randomly chosen small bottles. S1 plus S2 plus S3 plus S4 is less than 25.5 liters. So this plus this is less than 25.5. Why plus? Because it says total. So this is type 1 question. I will solve this later in this lecture. I'm just discussing types of questions right now. This is an important question. Find the probability that the volume of juice in a randomly chosen large bottle is at least twice. This is the product case. Twice means multiple. The volume of juice in a randomly chosen small bottle. So L is greater than 2S. This is the requirement. This 2 is multiple of S. You have to bring this on left side while solving this. We will solve this later. 6. The masses in kilograms of female and male animals of a certain species have the distribution normal. Find the probability that a randomly chosen female has a mass that is less than half the mass of a randomly chosen male. Again we have a product case. Half means times, multiple of m. Bring this on left side and we will solve this later. Properties of mean. Mean of constant is constant. This is the property number 1 or A. Let me explain this. If we have 4 observations and all observations are same, each equal to 5, then their mean must be 5. So mean of constant is always constant. So mean of 5 is 5. Mean of 8 is 8. Mean of B is B. So that's the property. Mean of constant is constant. Next property. E expectation bracket AX. This A is multiple of X. This is A times X. So while solving this, we can write this A outside the bracket like A times EX. For example, if we have 5X, so we can write this 5EX. And its example is here. Let's suppose we have EX is 3 and if we need to find 5x, E5x, so we can write 5 EX which is 5 times 3, 15. So that's the application of this property. Next, if we combine these two, this is the next property, ax plus minus b. Well, in expectations, signs must be the same. If we have plus sign, copy plus. If we have negative, copy negative. So this is for both plus minus. So a, according to this property, we can write this as aex plus b or minus b. Just copy these signs. Mean of constant is constant. This is according to this property. And its example is here 7x plus minus 5. So it should be 7 times ex plus minus 5. Mean of constant is constant. Next property, ax plus minus by. So we can write aex plus minus bey. In this example here, 5ex plus minus 3ey. If we have ax minus by, we can write aex, copy the sign, bey. For example, 3x minus 2y expectation, 3ex minus 2ey. Properties of variance. Number 1, variance of constant is 0 if each observation is same. If all observations are same, then their variation from their mean is 0. See, the variation of this observation from their mean is 0. So, since there is no variation, because all observations are same, so variance is 0. So if all observations are same, then variance is always 0. So variance of constant is 0. Next property, this a is multiple of x. So when you bring this outside the bracket, must square this coefficient. This is very important. This a is multiplying with x, so write a square. 3x means x is added 3 times. X plus x plus x, 3x. So this 3 is multiple of x. So when you bring this outside the bracket, write 3 square. 3 square times vx. Next property, ax plus b. So this is multiple of x, so a square vx, and the variance of constant is 0. So 5x plus 3. So write 5 square vx, and this is 0. Ax plus minus by, make sure variance can never be negative, so always replace negative, always change negative by positive. Both are positive. Positive remain positive and negative will become positive in variance. So a square vx and b square vy, and just write plus copy, and minus will become plus, because variance can never be negative. So these are the properties of variance. Now this is very important. If one variable x is added to 3 times, see, if one variable is added to 3 times, so this will become 3x. See, the mean can be written as ex plus x plus x. So when you will add this, you will get 3x. This 3 is multiple of x, but in mean we just copy this 3 times ex. In mean we never square the coefficient. In variance we do. So x plus x plus x. So this is 3x. That means 3 times of x. When you will bring this outside the bracket, it must be 3 square times vx. So 9 times vx basically. This property is extremely important. The whole chapter based on this property. Next, in this case, in the case of 3 independent observations, see, if we have sum of 3 independent observations of x, like x1 plus x2 plus x3, the mean can be written as ex1 plus x2 plus x3 bracket. So write ex1 here, ex2 here, ex3 here. So basically we have three means: ex, ex, ex. So it should be 3ex. 1, 2, 3. So 3ex. Similarly, for variance of these three independent observations, sum of three independent observations, write vx1 here, vx2 here, vx3 here, and this is equal to vx, vx, vx. So 3vx. So no, don't square this 3 because observations are independent. Just compare this property with this property. Here, one variable is added to 3 times x plus x plus x. So make sure you write in this way first. In variance, you square this coefficient. Here we have sum of three independent observations of x. So this should be 3ex, 3vx. If you find this video helpful, please subscribe, like and share the link. Don't forget to comment. Summary. So x is added to 3 times. So write this as e3x, then 3ex. For variance, v3x, when you will bring this 3 outside, it must be 3 square vx. This is just 3ex. This is just 3vx. Now practice questions. The random variable x has the distribution. So x is normally distributed. The random variable a is defined by a is 2x. So this means x is added twice. This is like this: x plus x. So this 2 is multiple of x. The random variable b is defined b x1 plus x2, sum of 2 independent observations of x. So b is x1 plus x2. Where x1 and x2 are independent random variables, describe fully the distributions. Describe means you have to write the name and their parameters. So for a, write EA 2x, so 2 times EX, so 2 times 3. This is EX. And Vx is 1.2. This answer is 6. V of A, V 2x, so it must be 2 square because 2 is multiple of x. So 4 times 1.2, which is 4.8. Now describe the distribution. So A is normal with mean 6 and variance 4.8. This is the way to describe the distribution of A. First get mean of A, then variance, and then write in this way. B. So first find E of B. So x1 plus x2. So this is 2ex. So 2 into, so basically you can write 2 into 3. You can also do this in this way. ex1 plus EX2, the alternative way. So 3 plus 3, which is 6. But this is the easiest way. Now V of B. So V of x1, x2, since we have two independent observations, just write 2 Vx. So 2 into 1.2. So this is 2.4. So B is normal with mean 6 and variance 2.4. This is the best question to understand this topic. And here is the summary. I mean, these two pages are very important. I'm sorry. Next question. The volumes in milliliters of large and small cups of tea are modeled by the distribution. So, large is normally distributed, small is normally distributed. Part A. Find the probability that the total volume of a randomly chosen large cup of tea and a randomly chosen small cup of tea is less than 300 ml. So total means sum. So L plus S is less than 300. We need this. So first we will work for their mean and variance. L plus S, EL plus ES. So EL is 200 and ES is 110. So this is 310. VL plus S. VL, VS. So 30 plus 20, that is 50. Now convert this statement into Z. Z less than 300 minus 310 divided by 50 under root. Now this will become S1 normal distribution from here. So Z less than minus 1.414. Make a rough sketch. So it should be 1 minus 5 because it's a small area. And answer up to 3 significant figure is 0.0787. Make sure you write 3 significant figures. Check the solution, please. Next question. Find the probability that the volume of a randomly chosen large cup of tea is more than twice the volume of a randomly chosen small cup of tea. So large cup L is more than twice of S. So we need this probability. L greater than 2S. So first bring 2S on left side. Now work for their mean and variance. Remember 2 is multiple of S. So EL we copy same sign in mean, but in variance we change negative to positive. We convert negative into positive because variance is always positive. And this 2 will become 2 square. because 2 is multiple of s. So make sure you always square the coefficient. Alright, so mean EL, so the mean of L is 200 and mean of S is 110. So this is negative 20. You can write this as mu, mean. Variance VL is 30 and VS is 20. So 30 and 20. This is 110. Now convert this statement into Z. Z greater than 0 minus mean, which is negative 20, divided by under root 110. So when we will simplify this, we will get Z greater than 1.907. Now make a rough sketch for phi or 1 minus phi. Check what is this. Small area, so 1 minus phi. Now write your answer up to 3 significant figures. Now check this solution, please. I'm sorry. Next question. Question number 3 from June 20, variant 6.1. The masses in kilograms of large sacks of flour and small sacks of flour, L and S, have the normal distributions. Find the probability total. Total means sum of 6 randomly chosen large sacks like L1, L2 till L6 is more than 245 kg. So we need this probability. L1, L2, L3 till L6, and this is greater than 245. So first we need their mean L1 plus L2 till L6. So this is 6 EL and EL is 40. So it's 240. This is mu. Now we need variance of these 6 observations. So 6 VL, don't square 6. We have 6 independent observations of L, and variance is 1.5 square. So this is 13.5. This is sigma square. Now we need to convert this statement into Z. Okay, so Z greater than 245 minus mu, which is 240, divided by under root 13.5. From this step, you use normal distribution of S1. You should be good at normal distribution. 1.361, make a rough sketch to avoid careless mistakes. Small area, so write 1 minus 5, 1.361, and give your answer up to 3 significant figures. The answer is 0.0868. Make sure regarding the accuracy, always give non-exact answers up to 3 significant figures. Please check the solution. I'm sorry. All right, next question. Find the probability that the mass of a randomly chosen large sack is less than 4 times of a randomly chosen small sack of flour. So again, 4 is multiple of S. So we need this probability. L is less than 4S. Now bring 4S on left side of the inequality and then work for their mean and variance. So EL minus 4S, it should be EL minus 4ES. EL is, let me check, what's the mean of EL? 40 and 12. So this is minus 8, you can call it mu. Variance L minus 4S. This 4 is multiple of S, so make sure you replace negative by positive, because variance is always positive, and square this 4. This is so important. Since 4 is multiple of S, so square this. Now VL 1.5 square and 0.7 square VS. 1.5 square 16 times 0.7 square. So this is 10.09. You can call it sigma square. Now convert this statement L minus 4S. I'm just copying this. L minus 4S less than 0. Now convert this into Z with the help of this formula. 0 minus mu, and mu is negative 8, divided by under root 10.09. Now get this number up to 3 decimal places, and the number is 2.519. Make a rough sketch to avoid careless mistakes. So 2.519 is here. So this is the required area, which is phi. Write the final answer up to 3 significant figures. Now check the solution, please. Next question. The independent random variables x and y have the Poisson distribution and binomial distribution respectively. Find the mean and standard deviation of x minus 3y. This 3 is multiple of y. So E x minus 3y, right? Ex minus 3ey and Vx minus 3y will become Vx plus 3 square, because 3 is multiple of y. Okay, now check the distributions. This is Poisson, x is Poisson. So let me first write x is Poisson with lambda 2, so its mean is 2, Ex is 2 and Vx is also 2. And x can take these values 0, 1, 2 till infinite. Now check the y distribution. Y is binomial 20 and 1 upon 4, n and p. So the mean of binomial is np np. So 20 into 1 upon 4, which is 5, and variance of binomial is npq. So npq is 3 upon 4. So it should be 3.75. And y can take these values 0, 1, 2 till n, which is 20. Now we need these values. So Ex, just substitute Ex and Ey here. Therefore, Ex minus 3y, write Ex, which is 2, 3, Ey is 5, so the answer is negative 13. Now Vx minus 3y, substitute Vx here, copy 3 square and Vy, just substitute Vy. Okay, so Vx is 2, this is here, plus 9 and Vy is 3.75. So this is 35.75. But we need standard deviation of x minus 3y. So just take the root of the variance. Make sure whenever you need standard deviation, first find variance and then state the standard deviation. So this is 35.75, which is approximately 5.98. That's it. This is the first answer and this is the second answer. Please check the solution. This is an important question. You must understand which values x can take and which values y can take. Both are discrete, both can take integer values. And the mean of Poisson is lambda, mean of variance of Poisson is lambda. Next part of this question. Now we have to find this probability, y is equal to 15x. So we need to check which values x and y can take. So we already have mentioned the values. So x can take these values, and y can take these values, because we have to solve this equation with respect to the values of x and y. Now substitute those values of x and y into this equation from these values so that this equation would be verified. So if I substitute x1 here, see, if I substitute 0 here, then I will get y0. So just check whether 0 is available or not. So 0 is available. So if x is 0, y is 0, and both values are available. So if x is 0, then according to this equation y is 0. So we have this set 0, 0. So, and both values are available in this list. Now the next value, if x is 1, then y would be 15 times 1 makes 15. Now check whether 15 is available or not. So in this list 15 is available. So this is the second set of values of x and y, 1 and 15. Now substitute x2 into this equation. So if we substitute 2 here, then we'll get 30, but 30 is not available in y. So x2 is not possible, okay, because 30 is not available in the list of y, values of y. So we have two possibilities for this equation. Y is equal to 15x. We need to find this probability 0, 0. This 0 means x and this means y. And we need x1, y15. Because for this pair and this pair, this equation is verified. Now x0 means, x means Poisson distribution. Remember, this means Poisson and this means binomial. So for Poisson, x0 means e power minus lambda. And lambda is 2. So this is for this. This is binomial. For binomial 0, q power n. Q is 3 upon 4 power n. N is 20. Okay. This is the value of x1. So use Poisson distribution. So it should be e power minus 2 lambda. Lambda e minus 2. So you should write 2 e minus 2. Okay, let me write the equation form, formula, to make it simple. So for this, it's e minus lambda. For this, q power n. This is lambda e minus lambda, this. And binomial 20c15 p power 15 q power 5. Okay, so solve this. 20c15, just copy this. P is 1 upon 4, 15, q is 3 upon 4, 5. Let me adjust this. Now the final answer is 0.000430, up to 3 significant figures. Please check this solution. I'm so sorry. I'm so sorry. Okay. Equations of y is equal to ax plus b type. Well, in equations, see, this a is multiple of x. Whenever equation is given, then the coefficient is always multiple of the variable. So for mean, write a ex and mean of constant is constant. For variance, square the coefficient, a square vx, and variance of constant is 0. We have done these properties earlier in this topic or in this lecture. Now this is the question of equation type. No? Exam marks x have mean 70 and standard deviation 8.7. So you can write this as x is mean of x is 70 I'm so sorry, and variance is 8.7 square, because standard deviation is 8.7. Now the marks need to be scaled using the formula y is equal to ax plus b, so that the scaled marks y have mean. So E of y is 55 and V of y is 6.96 square. Okay, so these informations are given, and this equation is also given, ax plus b. We need the values of a and b. So first take exponential on both sides of this equation. So e y, this is aex plus b. Ey is 55, copy a, ex is 70 plus b, call it equation 1. Now vy, vax plus b, so a square vx plus 0, variance of constant is 0. Now vy is 6.96 square, copy a square, vx is 8.7 square, call it equation 2. By solving these two equations, we can get the values of a and b. A is 0.8 and b is -1. Now check the solution again, please. To be good at this chapter LCR, we watch this lecture at least twice. The whole lecture, in fact. Next question. A mathematics module is assessed by an examination and by coursework. So there are two things: examination and coursework. The examination marks makes up 75% of the total assessment. Okay. So examination makes 75% and coursework makes up 25%. Examination marks X. So we can write 75% of X, right? Plus 25% of coursework, which is Y. This is the total mark. And the mean of X is 53.2, standard deviation 9.3, 78.0, 5.1. This is the total. So we need mean and variance of this. Find the mean and standard deviation of this. So first write E mean. So E 0.75x, 0.25y, so 0.75ex, 0.25ey, 0.75ex is 53.2, whereas ey is 78.0. Therefore, the mean of this equation is 59.4. Now variance. First find variance and then get the standard deviation. The square root of variance is standard deviation. Don't find standard deviation directly. Always find variance first. Now these are multiples of x and y. So 0.75 square Vx, 0.25 square Vy, 0.75 square Vx. Vx is, a standard deviation is given 9.3, so Vx is 9.3 square. 0.25 square Vy. Vy is 5.1 standard deviation, so 5.1 square. Hence the answer is 50.27 of variance, and standard deviation is under root 50.27, which is 7.09 up to 3 significant figures. Please check the solution. Two important concepts are left. This is the second last concept. Rules for modulus. If we have modulus of z less than a, then we write this as z lies between minus a and a. We did in S1 normal distribution. And this is the required region. We need this area. So modulus z less than a means z lies between minus a and a. So this is phi a and this is 1 minus phi a. And if we have greater sign, then we shade these two regions, z less than minus a or z greater than a. So for modulus greater than a, expand the modulus in this way, z less than minus a plus z greater than a. This is 1 minus phi, this is 1 minus phi. So just add these two, 2 minus 2 bracket 1 minus phi a. Please check these two again. When there is a lesser sign, shade this area and open the modulus in this way. Z lies between this and this. This area is phi a, whereas this area is 1 minus phi a. You know how to do this. We have done this in normal distribution. Phi a, 1 minus phi a. The main important concept is, if we have this, just shade this and expand the modulus in this way. If there is a greater sign, shade these two regions, get this area and just add these two. Now practice questions. Okay, a certain make of washing machine has a wash time with mean 56.9. We can call it W, or just you can say X, you have option. Mean 56.9, standard deviation 4.8. I'm writing this here. Wash time mean 56.9. Okay, let me write this here. 56.9 comma 4.8 square, and a certain make of tumble dryer. So drying time means 61.1, variance 6.3. Both times are normally distributed. Find the probability randomly chosen wash time differs means modulus, by more than 3 minutes from a randomly chosen drying time. So wash time from drying times. So if I say 5 is subtracted from x, then write x minus 5. So d minus w, d minus w is greater than 3. Differ means modulus, that is why I put modulus here. Please read this situation again. Let me charge the pencil because it's just 10%. I continue this in after 1 or 2 minutes. So it says wash time differs by more than 3 minutes from a randomly chosen drying time. So differs means put modulus d minus w modulus greater than 3. So we will expand this modulus in this way. We have greater sign, so we will expand this in this way. Z less than minus a, z greater than a. Please wait for 1 minute. It's 20%. Okay, let me continue. So expand this modulus in this way. D minus w less than minus 3 plus d minus w greater than 3. See, this is modulus z greater than a. So first write z less than minus a, put plus sign, then z greater than a. Now find mean and variance of d minus w. So mean ED is 61.1 minus 56.9. So the mean is 4.2. Variance. In variance, we replace negative by positive, or we change negative to positive. Negative into positive. So variance is 4.8 square, positive 6.3 square, which is 62.73. Now solve this. Convert this statement into z. Minus 3 minus mu, this is mu, this is sigma square. So 4.2 divided by 62.73 plus z greater than 3 minus 4.2 square root 62.73. Now get the simplified form of this. This is, let me check this. So minus 7.2 divided by square root 62.73. This is minus 0.909. Now check this one. So 3 minus 4.2 is negative 1.2 divided by square root 62.73. This is minus 0.15. Okay, so this is here on normal distribution curve. this is 1 minus 5. So 1 minus 5.909. This is 5 because we need this area. So 5 let me check this. 3 minus yeah, this is 5. .152. Okay, I'm leaving this for you. Just check the phi and write the answer. Okay. In order to save time, I'm not checking the phi. Okay, next question. Cans of drinks are packed in boxes, each containing 4 cans. The weights of these are normally distributed with mean 5, 10. So cans mean 5, 10. Variance is 14 square. The weights of the boxes when empty are independent, normally distributed with mean. Okay, so boxes normally distributed 208 square. I'm leaving first part because it says total weight. You just need to find W plus C. Okay, I'm interested in the second part, differ, this one. 2 cans of drinks. 2 cans means C1 and C2. Find the probability that they differ in weight by more than 20 grams. So we need this. Modulus C1 minus C2 greater than 20 grams. So first write this as C1 minus C2 less than minus 20, then C1 minus C2 greater than 20. Okay. Now C1 minus C2, get the mean. C1 minus C2. So 510 minus 510 is 0. Variance C1 minus C2, 196 plus 196. That is 392. So 0 and 392. Minus 20 minus 0 under root 392. Now z greater than 20 minus 0 divided by under root 392. Okay. So this is 0.101 negative. And this is 0.101 positive. This is 1 minus phi. This is also 1 minus phi because of small areas. Hence, the result up to 3 significant figures is 3.312. Please check the solution. Since mean is 0, that is why we got the same values here. But in this question, mean was not 0, so we got different values. Next question.